Retinoscopy is an objective technique used to determine the refractive error of an eye using light reflex. We're going to take you step by step through the process of carrying out your first retinoscopy examination. The average working distance is 66 centimeters. This is equivalent to 1.5 diopters. The practitioner's arm can be used to work out this fixation distance in most cases. Ask your patient to fixate on a non-accommodative or green target at 6 meters. This should ideally be done in a dim room to maximise pupil size. For examining the right eye, the practitioner should be situated on the right-hand side of the patient. Use their right eye and hold the retinoscope in their right hand. Likewise, for examining the patient's left eye, use your left eye, hold the retinoscope in your left hand and approach the patient from the left. Ensuring your retinoscope collar is down to use divergent light and that you're at a working distance of 66 centimeters, sweep the beam both vertically and horizontally across the pupil. So that your cylinder power is always in the negative format, we will try to find the most positive meridian and neutralize this first. The most positive meridian is either the slowest with reflex or the fastest against reflex. Spherical lenses are used first before moving onto the sill or astigmatic component. Once you have established the most positive meridian, if you notice a with reflex, i.e. the reflex moves in the same direction as the light, add positive lenses until there is no movement of the reflex. If you notice an against reflex, add negative lenses until there is no movement in the reflex. Once the reflex has been neutralized, we can move on to establish any astigmatic refractive error. With your sphere lens still in place, rotate the beam axes 90 degrees from the most positive meridian. Use negative cylinder lenses to neutralize this against reflex at this axis. This establishes both the power and the axes of the negative cylinder. When establishing the cylinder axis, I find it useful to use the handy para stop on the Heine retinoscope. This ensures the retinoscope beam stays parallel while you are rotating through the different axes. This makes locating the cylinder axes easier, quicker and more reproducible. Lastly, subtract your 1.5 diopter working distance from the spherical component to establish the patient's refractive error.